In the context of continental tectonics, Peter Molnar is really a true giant. This is the study of the building of mountains, of plateaus, how continents deform in relation to plate movements on Earth.
A large part of Peter Molnar's work has been concentrated on Tibet and the Himalayas, an area that was formed 50 million years ago but which is still an active deformation zone. A unique region perfect for earthquake and seismology studies.
In plate tectonics, you have the plates moving around the surface of the globe. And eventually this will bring a continent next to another continent. So the first stage is you have the rigid plate. If this is a continent, you have the rigid plate being subducted beneath the continent. Eventually another continent will come from over here, and when that meets the other continent, we have a big collision. And this is what's happening in the Himalayan Tibetan region. This is India colliding with Eurasia, continent to continent. And as soon as the continents collide, we cannot subduct anymore. The continents won't subduct. But these are plates which are still moving at 50 millimeters per year. There's nowhere else on the planet where we see this extent of continental deformation. And this is active deformation. What we're seeing, what Peter Molnar is showing us, is what's happening today. And this is an analog. This tells us what must have been happening, for example, in the Caledonides, the mountain chain that runs through Scandinavia and Scotland into the Appalachians. We don't really know how they formed. We have to go to an active deformation area like the Himalayas and Tibet. So that's really the key part of his work, is why he's concentrated on the Himalaya and Tibet, is because it's an active deformation zone. But in a more societal way, what he's done in earthquake studies, in the study of seismology in this region, is to make an awareness of the seismic risk. Obviously, when you have two continents colliding, you have all this faulting going on, you have seismic risk. You have big earthquakes, huge earthquakes. And this is a part of the world where hundreds of millions of people are living very close to the Himalaya. But at least part of his work is trying to understand that earthquake risk, understand the seismology. We see also the effects from the monsoon. We've seen in the past few years these horrendous floods in Pakistan, northern India. Part of Peter Molnar's work was to try to explain how uplifting Tibet and the Himalaya has an impact on essentially atmospheric circulation. And this impact changes the way the monsoon works. The monsoon strengthened in South Asia as a result of the uplift, the rapid uplift of the Himalaya and Tibet. This is not short-term climate change, this is a long-term climate change, but it's still showing how tectonics, how something that's being driven from deep in the earth by deep mantle processes, is actually affecting all the way up into the atmosphere and climate. Peter Molnar has not just studied rocks, earthquake mechanisms, but he's made this link between what's going on hundreds of kilometers down in the earth to what is going on in the bit of the earth we're living in now, the atmosphere, the surface of the earth. So I think that's a fantastic contribution.